Okay, so we want to go over page 8 and 9, number 35. And this is page 9, and this is 35. So we're drawing three lines that intersect at point J, but they don't all lie in the same plane, right? So if we were going to take this piece of paper as being our plane, and we were going to draw three lines all in the same plane, it would look something like that, right? But how would it look if all of them were not on the same plane? Well, one of them would be coming out of the plane, okay, like that. Okay, so let's go ahead and draw that. First, we need to draw the plane. So I'm coming here, and this is number 35. And the plane is going to look like this. And I'm going to call this plane P. I'm going to make it a little fancy, capital fancy. And I'm going to draw two lines on the plane. So remember, the lines are determined by 2 points, or noted by 2 points, and they continue off forever in opposite directions, right? So if I want to call this one A and this one B, and then I want to make another line this way that's going to go ahead and intersect at that point there, and I'll call this C and D, right? Well, then how can I make one line that's off the plane? Well, this one is on top of the plane, so I want to make it solid the whole way, right? But then down here, as it goes below the plane, it's dotted because it's behind the plane, okay? And then I'm going to continue this way like that. So I can make another 2 points if I would like, and I can say A, B, C, D, E, and F. So alternatively, you could go ahead and just label them with lowercase handwritten letters, right? Cursive letters. So this would be line L, line M, and line N. Okay, so this is one way you could have done it. Okay, so the next one is going to be 18 to 19. So I'm turning the page over there. And we're looking at numbers 17, 21, and 25. So number 17 is here. And we have this following information. We have ST, the entire segment is 4.1 inches. And then we have each part of the segment. We have SV, which is what we want to find out. And we have VT, which is what we have. Okay. And so using the segment addition postulate, if I go ahead and pull out the notes right here, right? It says that a segment is composed of the addition of the measure of its two parts, right? So if we have this segment here, well, PQ is equal to PM plus MQ, right? So if we're back over to here, okay. If we are back over here, then what we can say, I'm going to put number 17 right here. I could say SV plus ST, I'm going to do segments on top, is equal to I made this wrong. So SV plus VT. So not ST here. It's going to be VT is equal to ST. Did I get that right? Yes, the big one is ST. Okay, so the entire segment is composed of the addition of the two parts. Okay, and then we know a couple of these values. So ST is 4.1, so I could plug that in, 4.1 right there, right? And then VT is 2.6, so I could plug that guy in right here. Okay, and then I'll go ahead and finish up the equation. And we could see that we just have one variable, right? One unknown, and that's the value of SV. And that's actually what we want to find out, right? That's what the question is asking us. So we can go ahead and solve for SV, right? And we can subtract 2.6 from both sides. So minus 2.6 minus 2.6. We'll get SV on one side, and we'll say that it is equal to, okay, well, this is a little bit complicated, so I'm going to have to borrow one. And I got 11 minus 6, that's 5. Then this, since I borrowed one from the 4, that guy's going to turn into a 3, and I'll do 3 minus 2, and that's a 1. So we get SV is 1.5. Okay. And then the next one you guys wanted was number 21, I believe. Yep, 21 and 25. So 21 is here, and this is the same problem as what we just did, right, with the segment addition postulate, except they don't give you the drawing. Okay, so let's go ahead and draw this out. So we're doing number 21, and the first part of 21 is to draw it out. So what's the value of the variable and yz if y is between x and z? So I'm going to go ahead and draw this right here. Y is in the center. It's between x and z. Okay, and we have some of these values here. So we have for 21, it's xy is equal to 11. So I can go and label this guy. Xy is 11. And then yz is 4c, so yz is 4c. And then they also give us the entire segment, so we got xz is 83. So xz, so from there to there, is 83. Okay, so we have our, man, I keep having to pull this out, but we have our segment, whoa, that's not right, that's not the right page. We have our rule for segments, right, which is that a segment is equal to the sum of its parts, right? So we can come over here and we can write that same equation. So it's xy plus yz, this segment here, is equal to the entire thing, so xz. Okay, so now that we got our equation set up, we can go ahead and plug everything in. So 11 goes here, plus 4c goes here, and then we got 83 on the far end. And now we can solve for c, because that's what the question is asking for right here. It's saying find the value of the variable. And what is the variable? Well, the variable is the c, right? That's c right here. And not only that, but also find yz. Okay, so we want c and yz. So first thing we want to do is solve for, solve for c. So we're going to subtract 11 from both sides. That gives us 4c is equal to 72. Then we divide by 4 on both sides, and that gives us 1, 8, right? Because 4 goes into 7 one time. And then we got 32 left over. So 4 goes into 32 8 times, right? So we get 8. And so we got c is equal to 18. Great. So now we want to find yz. Well, yz, the segment, is equal to 4c, right? And that's another way of saying 4 times c. So we're going to plug c back in, and we'll say 4 times 18. And you could punch that in a calculator, or you can work it out. And I do 2, carry the 3. 4 times 1 is 4, and I add the 3, and I get 72. So that's the answer, and that's the answer, right? These two guys. Oh, I'm sorry. Those two guys, right? So this guy here and that guy there. Okay, so that's 21. Ooh, let's see. What else is there? It's 25. Okay, so 25 is right here. So we have the similar problem, except we have a more complicated expression for the segment parts, right? So let's do 25. So 25 means that xy plus yz is equal to xz, and this is the same drawing that I have here, right? That's why I'm not drawing it out again. Okay, so that's the equation, and now let's plug everything in. So we get 4n plus 3 plus 2n minus 7 is equal to 22. Okay, now we have this equation that we need to work out. Oh, okay, I thought I made a mistake. I put 2x right here, but this is supposed to be 2n. Okay, and so now we solve for the variables. So let's go ahead and combine like terms. That's 4n and 2n. It becomes 6n. And then we got 3 minus 7, that's negative 4, is equal to 22. We add 4 on both sides of the equation. We get 26. Yeah, I think that's right. Okay, and then we divide by 6 on both sides. So we get n is equal to 4 and 2 6. So n is equal to 4 and 1/3, right? Okay, so that's like a messy little number that we got there. Let me double check my math to see if it's correct. So negative 4, that's right. We got 6, yes. We add 4, that's 26, yep. Okay, so the math looks good. We got this messy number, and now we need to find yz. Okay, and what is YZ on number 25? Well, YZ is that guy. So hopefully it all clears up once we plug in the numbers for YZ. So we get YZ is equal to 2n minus 7. Okay, then we're going to plug n in. So then YZ is equal to 2 times 4 and 1/3. And then we're going to do minus 7. And we're going to work this out. So let's see. So we do, I'm going to turn this guy back into a fraction. So we do 3 times 4 is 12 plus 1. So that is 13 over 3 times 2 minus 7. And then I could put a 1 under that 2, and then just multiply straight across, right? So I'm going to say is equal to 26 over 3 minus 7. And yes, it does clear itself up, okay? So we say equals, or does it? No, it doesn't. So we get 7, 8. So I believe it's 8 and 2/3 minus 7, right? So if you see how many times 3 goes into 26, and that's 8 times, right? And then that's 24. So then we need 2 more to get 26 from 24. So that's how I got that 2 on the top. And then finally, we're going to go ahead and subtract. So we get 1 and 2/3 as the value of YZ. And then we got the value of n, which is 4 and, oh, wrong one, 4 and 1/3. Okay. So yeah, what it all boils down to is this, right? A segment is equal to the sum of its parts.